Angus Webb. I'm the CEO and founder of Dynamon. And we're a spin-out from the University of Southampton Engineering Department, and we're based in the Southampton Science Park. So Dynamon's a data analytics company that provides data analytics tools to help the commercial transport industry maximize their sustainability. Historically, we've been working with fleets to help them minimize energy consumption, minimize fuel costs. But more recently, we've been developing our latest tool, Zero, which is a data analytics tool to help transport companies transition from internal combustion engine vehicles to zero emission vehicles. And obviously, this presents a pretty significant challenge for the industry because the feasibility of zero emission vehicles and the cost is not very well understood. And therefore, there's a strong demand for a digital solution that can help companies understand the optimum zero emission vehicle solution before having to start purchasing these vehicles and infrastructure. So we've developed Zero, and what Zero does, it provides accurate real-world performance insights for electric vehicles within specific fleet operations. It enables fleets to choose the best EVs for their operation, and also enables them to optimize their charging infrastructure investments. And on the bottom of that list, I'm saying it also enables EV mobility as a service business models. This is something that we believe is going to change the industry quite significantly. There's going to be new business models that crop up as a result of this significant challenge of going to EV. And we think having a tool that enables the optimization of the complete system will mean that there'll be companies that will be able to provide both the infrastructure, the energy costs, and the vehicles as a single package. So how Zero works is displayed on the diagram on the right there. So the key inputs to Zero are fleet telematics data. Zero is integrated with the top telematics providers globally, and it's also integrated with fleet routing data. So whether you've got a historical operation that you want to model EVs on, or you want to perhaps model a different operation in the future, if you're building a new depot operation, you can use routing systems as well, such as Paragon. Zero was originally developed initially for the small vehicle market, for vans, and we've built our own testing program to test a number of different vehicles to develop our own EV performance database. And in this project, we worked with Magtech to directly get their vehicle into the EV performance database. And that was one of the significant activities in this project, was getting the Magtech vehicle into Zero so that it can be accurately modeled within a specific fleet operation. So the key outputs of Zero are the ability to identify the optimum EVs for a specific fleet operation, identify where EVs can replace internal combustion engine vehicles, identify the optimum charging infrastructure to ensure that these EVs can continue to perform the required operation. And what's very important and often overlooked is understanding the electricity demand from EV charging to ensure that you'll be able to charge these EVs with the electricity infrastructure you have, or understand whether or not you need to modify your infrastructure to provide the energy for EV charging. So this project worked with NHS Wales, and NHS Wales operate a fleet of heavy goods vehicles, and the analysis of this project focused on 3 depot locations: Denbigh in the north of Wales, Bridgend in the south, and Greenville in the south. NHS typically operated 15 to 18 ton Mercedes rigid vehicles, and therefore the Magtech 18-ton vehicle was a good replacement in terms of a vehicle specification for these vehicles. But what wasn't understood was whether an EV could perform this operation from these depot locations. So Zero was integrated with NHS's telematics provider, and 3 months of historical data were analysed. And you can see that on the map there. So you can see the operation in the north, and then the 2 depot locations in the south. But you can see the journeys extending deep into Wales. So there's some very long journeys and driving being performed by these vehicles. So it's critical to understand whether the EV can perform these diesel vehicle operation and journeys. This data was input into Zero, and the Magtech vehicle, the 18-ton Magtech vehicle, was modeled on these existing journeys. And this is a screenshot from Zero displaying the results. And on this results page is the performance of the Magtech vehicle for 3 different battery sizes for the 3 different depot locations. And you can clearly see the bars there in the bar charts of how the Magtech vehicle performed on these journeys. Where the bar is green, the vehicle is able to complete that full day of driving and all the journeys within that day. And where the bar is red, is where the vehicle would not have been able to complete the driving. As you see, as we increase the battery size, there is significantly more green and less red, and therefore the vehicle is able to complete the more of the driving. If we look at the 180 kilowatt hour data, you can see that for 2 of the depots, over 60% of the journeys are completed. And for one of the depots, Greenvale, about 30% are completed. If we increase the battery size to 240 kilowatt hours, you can see that the vast majority of the journeys and days of driving are completed. And if we further increase the battery size to 300 kilowatt hours, you can see that, yes, more of the journeys are completed, but there's clearly diminishing returns that are happening. So there's obviously some journeys in there and some parts of the operation that it appears with, if you increase the battery size, you still don't manage to complete all the journeys. So what this is showing is that there's clearly an optimum here around the 240 kilowatt hour battery size, with diminishing returns going any higher than that. And that's really valuable information for when you're investing in your future EV fleet, that you're not over investing in battery size and getting significant diminishing returns. However, there's still some red there, and we need to understand what's going on in these journeys that's causing some of the operation to not be completed. And Zero enables you to drill down and to look on an individual journey basis to really understand, as a fleet manager, what's going on in my fleet that is, going to be challenging for an EV vehicle to perform. So this is an example, a single example. We're going to give you a deep dive of what you can do with this tool to really look at precisely what's going on in your fleet. So there's the list of all the individual journeys performed by a specific vehicle, and we can start to really understand the performance of an EV on one of those specific journeys and learn what we can do about it. So we've talked about battery size, but what's also really important is understanding the impact of charging power. At the Denbigh depot for NHS Wales, there's quite a lot of return to depot throughout the day, and therefore there is an opportunity to plug those vehicles in during the day and top the battery up whilst the vehicle is stopped before it goes back out on its next journey. So if you look at this graph here, you can see on the bottom right is the state of charge of the vehicle when there's no daytime depot charging happening. You can see the vehicle leaves the depot with 100% charge, and that battery drains throughout the day and eventually turns red, and that would be a case where the vehicle would not have managed to complete the driving. And you can see the points on the map where it's red. Most of that driving is not possible. But what we're able to do is to select a different charging power. So in this case, it's currently set to 0 kilowatts. But if we were to increase it to, say, 20 kilowatts, so plugging the vehicle into a 20 kilowatt charger at the depot, we can see the impact on the next slide. So this shows we've plugged the vehicle into the charger at the depot, and you can clearly see on the graph on the bottom right the impact that has. When the vehicle stops, the battery is being topped up, and significantly more of that graph and of that journey is green and being completed. And you can see there on the map that more and more of that journey is being completed, but a little bit at the end of the day, when the vehicle's on its way back to the depot, it's still not quite making it. So if we can investigate an even higher charge power, so if you go to the next slide, we can see what happens when we apply 40 kilowatts of charge whilst the vehicle returns to depot. And now the whole journey has gone green. So this is an example of how you can really identify what solution is required to enable your EV to perform your operation. And you're able to adjust different battery sizes, different charge powers to really understand what the optimum solution is, because you might save significantly if you can just get away with a bit of depot charging instead of investing in very, very large batteries. The counter to that is that maybe you don't return to depot and you're going to need a bigger battery, or you're going to need to utilize the public charging network. And so I just wanted to give you an example of the level of detail that this can go to. And you can also aggregate all this data back up to see a general view as to what depot charge powers and what battery sizes are optimum for your fleet operation. So as I mentioned, electricity demand is going to be a major challenge for EV charging. And Zero also is able to predict location-specific electricity demand across times of day for different charging powers for your vehicles. And so what this is showing is the predicted electricity demand from EV charging at the Denbigh location for NHS. And there's 3 curves on this graph. The red curve is the absolute maximum that you'd ever expect based on the vehicle movements from the telematics data. The blue shaded area is the general range, and the dotted line is the average. And you can see clearly there on that graph at 2 p.m. there's going to be a peak if you use a 100 kilowatt charger, and that peak may go up to 400 kilowatts of electricity demand at that time. And at that location, that electricity may not be available without significant grid enhancements due to the other loads that the grid is experiencing. But you can also see on that graph in this example that by 6 p.m. there's no demand from charging because using 100 kilowatt charging has topped the batteries up very rapidly, and the chargers turn off, and therefore there's no demand. That's maybe not the best utilization of your energy at that time of day. So if you go to the next slide, we can see the impact of charging at, say, 20 kilowatts. You can see that significantly reduces the energy demand at 2 p.m. and spreads that energy cost or that energy demand over the whole day. And obviously you need to balance this by looking at whether the vehicle can complete the journey and ensuring that you've got a solution that is robust for most of your fleet operation. So that's just a quick example of the capabilities of Zero. It's a tool that we've designed to both provide very deep dive information to really refine and optimize your fleet operation, but also to give you a general overview to identify what vehicles and charging infrastructure are optimum for your fleet operation.